Imagine, if you will, a colossal creature weighing 9 tons, moving deliberately along the edge of a forest clearing. Its head bears 3 formidable horns, with the central one extending over a meter in length. Behind it, a massive bony frill fans out, possibly adorned with vibrant patterns. The ground trembles subtly with each step it takes. This is not a predator, but a Triceratops, a creature that many scientists regard as one of the most formidable herbivores to have ever roamed the planet. Moreover, it was among the last dinosaurs to witness the end of the Mesozoic era. The iconic trio of horns and the imposing frill are merely the surface of a much deeper, more enigmatic story. Beneath this exterior lies a complex and uniquely fascinating being. The Triceratops represents not just a relic of the past, but a symbol of strength and resilience in the face of a changing world. Examining the anatomy of this living fortress reveals why the Triceratops is so instantly recognizable. It was one of the largest terrestrial animals of its time, with a body length stretching between 8 and 9 meters and a shoulder height of approximately 3 meters. Its weight ranged from 6 to 9 tons. Although certain larger individuals may have tipped the scales at an estimated 12 tons, rivaling the modern African elephant, yet far more robust and squat. The Triceratops' body was dense and barrel-shaped, supported by 4 powerful limbs. The forelimbs were relatively short and splayed outward, reminiscent of a rhinoceros, while the hind legs were longer and more upright, providing stability rather than speed. Estimates suggest it could reach speeds of around 24 to 28 kilometers per hour, impressive given its massive size. Yet, the true hallmark of the Triceratops was its extraordinary head, disproportionately large even among giant dinosaurs. The skull reached lengths of up to 2.5 meters, making it one of the largest of any land animal in Earth's history. Remarkably, the head constituted nearly a third of the animal's total body length. Atop this immense head were 3 horns, 2 long, powerful brow horns above the eyes, which in mature individuals span from 90 centimeters to over a meter, and a shorter nasal horn around 30 centimeters in length. These horns consisted of a bony core sheathed in a keratinous covering, similar to modern bovines or antelopes, suggesting they were even longer in life than fossil evidence alone indicates. The Triceratops' bony frill, the squamosal shield, was served multiple purposes: a display for attracting mates, a deterrent against predators, or a means of thermal regulation. In the twilight of the dinosaur's reign, the Triceratops stands as a testament to the adaptability and evolutionary prowess of life on Earth, a reminder of the intricate tapestry of existence that has unfolded over millions of years. In the annals of paleontological discovery, the Triceratops stands as a testament to nature's grandeur and evolutionary ingenuity. This magnificent creature, a member of the ceratopsian family, was distinguished by its formidable headgear, a bony frill that extended nearly a meter in diameter. Intriguingly, this frill was not merely a static structure, it was interwoven with a sophisticated system of blood vessels. This vascular network allowed the frill to change color, possibly blushing with blood to communicate visually. Such a feature suggests a multifaceted utility, from displays of dominance and courtship rituals to signaling alarm. The edges of this impressive frill were adorned with small bony projections known as epiossifications. In Triceratops, these projections were rounded and modest compared to the more pronounced, spiky adornments of its ceratopsian kin. This subtlety in design aids paleontologists in distinguishing Triceratops from its closest relative, the Torosaurus. The purpose of this frill remains a subject of fascination and debate, which will be explored in greater depth as we delve further into the chronicles of this dinosaur. Turning to the Triceratops' dentition, we uncover a marvel of a formidable dental arsenal. Its mouth housed a complex battery of teeth, arranged in multiple rows that continuously replaced themselves as they wore down. Estimates suggest that an individual Triceratops could harbor between 400 and 800 teeth at various stages of development. This dynamic dental system rendered the Triceratops an efficient processor of tough met tool, adept at slicing and gathering plant matter with remarkable precision. The powerful jaw muscles, anchored to the frill, conferred an extraordinary chewing force, enabling the Triceratops to outpace many of its herbivorous contemporaries in fits. The texture of the Triceratops' skin, as inferred from rare fossilized imprints, was adorned with polygonal scales of varying sizes, larger across the back and smaller along the flanks and belly. No evidence has surfaced to suggest the presence of feathers or down, although some researchers entertain the possibility of simple dermal structures in certain body areas. The saga of the Triceratops' discovery is itself a captivating narrative, set against the backdrop of one of the most thrilling scientific rivalries of the 19th century. This tale begins with an unexpected twist, a misidentification that nearly obscured its true identity. In the year 1888, amidst the rugged terrain of Colorado, USA, geologist John Bell Hatcher stumbled upon a pair of massive horns protruding from the earth. The sheer size of these horns was awe-inspiring, yet their initial interpretation was astonishingly off the mark. The renowned paleontologist Othniel Charles Marsh, upon examining the find, concluded that these were the horns of a colossal ancient bison. To contemporary eyes, this judgment might seem peculiar, yet at the time, the notion of gigantic horned mammals was not far-fetched. Thus, the Triceratops, now a symbol of prehistoric might and mystery, was nearly lost to the annals of paleontology due to a mere oversight. This misinterpretation underscores the challenges and surprises inherent in the scientific pursuit, reminding us that the quest for knowledge is as much about re-evaluation and discovery as it is about the initial findings. In the dance of history and science, the Triceratops remains a poignant reminder of the intricate tapestry of life that once roamed the earth, inviting us to ponder the endless wonders that lie hidden beneath the surface of our world. In the annals of paleontological discovery, few moments stand as vivid and controversial as the unveiling of the Triceratops. Initially mistaken for a horned bison, the first fragmentary fossil discovery by John Bell Hatcher was re-evaluated by the eminent paleontologist Othniel Charles Marsh. In the year 1889, Hatcher unearthed a more complete skull, dispelling any remaining doubts. This was no mere mammalian relic, it was the skeletal remains of a dinosaur, but not just any dinosaur, a creature of remarkable peculiarity. Marsh bestowed upon this ancient behemoth the name Triceratops horridus, translating from Greek to mean three-horned face. The term horridus, denoting roughness, alluded to the texture of the fossilized bones. This discovery emerged during a period known as the Bone Wars, a fierce and oftentimes unscrupulous rivalry between Marsh and his contemporary, Edward Drinker Cope. Their quests for dominance in paleontology led to grand expeditions across the American West, where they competed to unearth and catalog new species with feverish intensity, occasionally at the expense of scientific accuracy. Amidst this backdrop of rivalry, the Triceratops became one of Marsh's crowning achievements. From the late 19th century to the dawn of the 20th, Hatcher and his colleagues extracted over 50 Triceratops skulls, rendering it one of the most extensively represented dinosaurs of its era. These findings illuminated the creature's prevalence across the late Cretaceous landscapes of what is now the western United States. Yet, the classification of Triceratops proved to be as intricate as the creature itself. Over the decades, numerous species were proposed: Triceratops prorsus, Triceratops elatus, Triceratops sulcatus, among others. By the mid-20th century, the list burgeoned to approximately 16 distinct species. Subsequent taxonomic revisions have since distilled this list to two principal species, Triceratops horridus and Triceratops prorsus, differentiated primarily by skull proportions and nasal horn size. A separate, long-standing debate surrounds the Triceratops classification as a distinct genus or as a juvenile form of the Torosaurus. In 2010, paleontologists John Scannella and Jack Horner posited a provocative hypothesis. What has been identified as Torosaurus, with its elongated and ornate frill, might actually represent the mature form of Triceratops, with the latter being merely its juvenile counterpart. Under zoological nomenclature, should this theory hold true, the name Triceratops would take precedence, potentially erasing the name Torosaurus from scientific lexicon. However, this hypothesis has not withstood the scrutiny of further research. Studies examining the bone microstructure of adult Torosaurus specimens reveal that their growth had ceased, indicating a fully mature stage, distinct from that of Triceratops. The tale of Triceratops is emblematic of the ever-evolving nature of scientific understanding, a testament to the complexities and wonders of Earth's prehistoric past, where each discovery is but a stepping stone towards the greater truth hidden within the sands of time. In the realm of paleontological exploration, the Triceratops stands as a fascinating testament to the dynamic interplay of evolutionary forces. Once perceived as an ancient creature merely continuing its growth, today it is recognized by the majority of paleontologists as a distinct genus, closely related yet separate from its counterpart, the Torosaurus. This ongoing debate over their precise relationship exemplifies the ever-evolving nature of scientific inquiry. A significant portion of our understanding of the Triceratops has been shaped by discoveries within the Hell Creek Formation, a geological layer sprawling across the states of Montana, North Dakota, South Dakota, and Wyoming. This formation has yielded the richest collection of Triceratops fossils, situated alongside the remains of its formidable contemporary, the Tyrannosaurus rex. The coexistence of these two titans was no mere coincidence. They roamed the same landscapes, their paths inevitably intertwined. The Triceratops is perhaps best known for its iconic frill and horns, features that invite both intrigue and debate. The purpose of these formidable structures is a question that, at first glance, seems straightforward, but is in reality deeply complex and contentious within paleontology. While the instinctive response might be that these features served as defensive mechanisms, this explanation only scratches the surface of their true function. The two prominent brow horns of the Triceratops undoubtedly served as fearsome weapons. Their impressive length, robust bone density, and strategic angling suggest they were adept at delivering powerful strikes and deflecting assaults. However, the frequency with which these horns were utilized for defense remains a matter of open inquiry. Key evidence lies in the markings found on the bones themselves. Triceratops skulls exhibit distinctive damage, scratches, gouges, and bite marks, some of which are clearly inflicted by predators, including the Tyrannosaurus. Yet, a notable portion of these injuries, particularly the scratches and indentations on their frills, originate from a different source. The pattern and placement of these marks align precisely with the horns of another Triceratops, providing compelling evidence that these creatures engaged in combat with one another, horn against horn. Such behavior is well documented among modern horned animals such as deer, goats, and rhinoceroses. During mating seasons, males engage in ritualized battles to establish dominance and secure mating rights. These confrontations typically involve locking horns and shoving matches, designed more to assert power than to cause significant harm. It appears that Triceratops engaged in similar intraspecies contests. Their horns were primarily tools for these social competitions rather than constant weapons against predators. The frill, however, presents an even more intricate narrative. Long considered a shield to protect the neck from the lethal jaws of the Tyrannosaurus, this notion, while intuitively appealing, is fraught with challenges. Despite its imposing appearance, the Triceratops frill was not particularly robust from a mechanical standpoint. Its central portion was relatively thin, laced with large blood vessels, and, according to biomechanical analyses, lacked the structural integrity to serve effectively as armor. Thus, thick cognition, or as a display structure in social interactions. The true significance of these features continues to inspire debate and research, reflecting the vibrant and ever-changing landscape of paleontological science. Each fossil unearthed, each hypothesis tested, brings us a step closer to understanding the rich tapestry of life that once thrived on our planet, reminding us that the pursuit of knowledge is an endless journey, ever unfolding with new mysteries to uncover. A formidable bite from the fearsome Tyreus, compelling observation led scientists to seek alternative explanations for the Triceratops' evolutionary design. Emerging from these inquiries was a theory centered around communication. The frill of the Triceratops, interwoven with a complex network of blood vessels, possessed the extraordinary ability to alter its color and appearance based on the animal's physiological state. This vibrant display could signal a variety of messages: excitement, readiness to mate, or a warning of impending danger, transforming the frill into a dynamic canvas of expression. A pivotal study conducted in 2021, led by paleontologist Andrew Farkey and his team, unveiled a fascinating discovery. They found that the frills of Triceratops bore a significantly higher degree of damage compared to other parts of the body. The nature of these injuries suggested they were inflicted during the creature's lifetime and had time to heal, indicating frequent intraspecific confrontations where the frill bore the brunt of horned clashes. This aligns with a multifaceted model accepted by many experts today. The frill and horns serve dual purposes: instruments of communication and tools for competition. They played roles in visual displays, mate attraction, and establishing dominance, while also providing defense in genuine threats. Such multifunctionality is a common theme in the tapestry of life. An intriguing question lingers. Could a Triceratops triumph over a Tyrannosaurus in a direct encounter, one-on-one, with no retreat possible? This debate continues to captivate scientists, each camp armed with compelling arguments. The frill also evolved as the Triceratops matured, presenting another layer of complexity. Juveniles possessed relatively small, rounded frills, which elongated and assumed their distinctive shape with age. The horns, too, underwent transformation, from rearward-facing in the young to forward and upward in adolescence, and finally pointing forward in adult. These ontogenetic changes, describing the developmental journey of an individual, once puzzled scientists, leading them to mistakenly classify different growth stages as separate species. Yet, the size and brill, more vibrant frill, signaled maturity and strength, offering a straightforward, efficient system of visual assessment without the need for physical confrontation. A mere glance could reveal much. This logic mirrors that of modern animals adorned with extravagant features: peacocks, deer, and mandrills, to name a few. The legendary clash of the Triceratops and Tyrannosaurus remains an enduring narrative of the Mesozoic era, one that has sparked the imagination for over a century. The first discovery of their fossilized remains, the debate over this iconic rivalry continues to resonate, illustrating the timeless allure of nature's most dramatic spectacle. In the vast expanse of late Cretaceous North America, an extraordinary drama unfolded, one that echoes through the annals of paleontological history. Tyrannosaurus rex, the apex predator of its time, and Triceratops, the formidable shield-bearer, coexisted within the same prehistoric landscapes, specifically the Hell Creek Formation, approximately 68 to 66 million years ago. This was no mere coincidence noted in textbooks. It was a real and dynamic ecological interaction. Both species roamed this ancient terrain, breathing the same air, drinking from the same rivers, and leaving behind a legacy etched in the fossil record. The bones of Triceratops tell tales of survival and conflict, bearing the unmistakable marks of Tyrannosaurus teeth. These bite marks raise a compelling question. Were they the result of a hunt, or merely the aftermath of scavenging? The evidence is tantalizing. Bite marks on the horns and frill of Triceratops suggest a peculiar focus by the Tyrannosaurus on these less fleshy parts, indicating behavior more akin to a scavenger than a predator. Yet the story does not end there. Some Triceratops fossils GDK reveal injuries that healed during the creature's lifetime, suggesting encounters with a predator from which they managed to escape, showcasing their ability to defend themselves. The biomechanics of such encounters have been the subject of extensive computer simulations. Tyrannosaurus rex wielded an awe-inspiring bite force, estimated at around 245 kilonewtons, capable of crushing bone. However, the Triceratops was no easy prey. It matched or exceeded the predator in weight and possessed a lower, broader build that would have made it difficult to topple. While the Tyrannosaurus's forelimbs were notably short and weak, the real power lay in its jaws. To deliver a lethal bite, it needed to circumvent the formidable horns of the Triceratops. Computational models suggest that an attack from the rear or side posed significantly less risk to the predator than a frontal assault. The Triceratops, with its substantial bulk, could pivot swiftly enough to keep its horns aimed at any perceived threat. Intriguingly, the majority of Tyrannosaurus bite marks discovered on Triceratops skulls appear on the frill and rear of the skull, areas accessible from behind or the side. This distribution of evidence supports the hypothesis that effective predatory strategy required the Tyrannosaurus to outmaneuver the defensive capabilities of its prey. In this prehistoric theater of life, the interactions between these two titans were not merely battles of survival, but intricate dances of evolution, each species adapting and counter-adapting to the other's strategies. Their story is a testament to the relentless forces of nature, shaping life through conflict and competition, and leaving us with a profound understanding of the delicate balance between predator and prey. In the annals of paleontological discovery, the narrative of the Triceratops is woven with tales of both vulnerability and formidable resilience. Fossil evidence reveals that some Triceratops bore broken horns, fractures suggestive of powerful lateral blows. Such injuries could have resulted from fierce clashes with their own kind or from dire encounters with Paleontologists have interpreted these findings as potential evidence of the Triceratops engaging offensively against the Tyrannosaurus, possibly using its imposing horns to strike at the predator's body or limbs. This paints a dynamic picture of their interactions, challenging the simplistic notion of a one-sided victory. It was not always a case of Tyrannosaurus domination or Triceratops defiance. Rather, it was a complex interplay of situational dynamics between two colossal and perilous creatures. The vulnerability of a young or weakened Triceratops stood in stark contrast to the formidable presence of a healthy adult male, weighing 9 tons and armed with meter-long horns. A Tyrannosaurus, with its pidules. This prehistoric rivalry has transcended time to become a cultural phenomenon immortalized in museums, literature, films, and video games. The Triceratops and Tyrannosaurus rex are emblematic of two opposing forces within the same ecosystem, the apex predator and the pinnacle of herbivorous defense. Both were integral components of the late Cretaceous landscape, each playing a pivotal role in the balance of their shared environment. The life of a Triceratops, its behavior, social structure, and habitat remains a subject of fascination and mystery. While we have reconstructed its physical appearance and dietary preferences, questions about its social behavior persist. Did the Triceratops roam in solitude or as part of a herd? What were the dynamics within its group, and what environments did it favor? These questions remain some of the most intriguing and challenging to answer, as behavior leaves few tangible traces in the fossil record. Yet clues can be gleaned from the sissels are predominantly found as solitary specimens. Mass burial sites, common among the solitary or small group lifestyle. However, discoveries of 2 or 3 GDC found together hint at the possibility of a more complex social structure. Drawing parallels with modern, large-horned mammals, such as rhinos and buffalo, suggests a mixed strategy. Males may have lived solitary lives, GDC from small bachelor groups, while Triceratops thrived in the floodplain forests and open landscapes of the late Cretaceous western coast of North America. This region, now vastly different, was once characterized by a warm climate, lush vegetation, and intricate river systems. The Western Interior Seaway, an epicontinental sea, shaped this environment, offering a rich tapestry of life for the Triceratops and its contemporaries. In contemplating the existence of these prehistoric giants, we are reminded of the intricate dance of life and survival that played out eons ago. Their story is one of adaptation and resilience, a testament to the enduring mysteries of our planet's ancient past. In the ancient tapestry of Earth's history, a time existed when the vast continent of North America was cleaved in two, cradling a humid, temperate climate. This environment, rich with life and abundant rainfall, fostered a verdant world perfect for the colossal herbivores that roamed its expanse. Among these giants, the Triceratops thrived, its diet a testament to the diverse vegetation of the late Cretaceous period. This formidable creature feasted on tough, fibrous plants, palms, ferns, cycads, and perhaps the nascent angiosperms, which were beginning to carpet the planet. The Triceratops, with its robust neck and unique cranial structure, was adept at grazing vegetation no higher than a meter above the ground, distinguishing it from the towering sauropods who reached for the treetops. The movement and migratory patterns of the Triceratops remain a tantalizing mystery. Modern large herbivores, such as elephants, buffaloes, and bison, undertake seasonal migrations in search of sustenance and water. Could test this possibility. The widespread discovery of Triceratops fossils across the Hell Creek Formation indicates a vast territorial range. Isotopic analysis of dental enamel from some specimens reveals varying geographic sources of water throughout their lives, hinting at potential migrations. The growth and development of the Triceratops present another intriguing dimension. By examining the annual growth rings in their bones, akin to those in trees, scientists have determined that young Triceratops grew rapidly, slowing as they reached maturity years, though some evidence suggests they could live longer. Juvenile, or within the safety of the herd, until they grew large enough to fend for themselves. Discoveries of small ceratopsid fossils in areas populated by adult Triceratops lend support to the notion of parental care, although the extent of such care remains a matter of debate. Recent breakthroughs in paleontology have arisen from the study of trackways, large, rounded footprints with distinctive patterns preserved in the sediment of the American West. These tracks offer a glimpse into the locomotion and behavior of these ancient creatures, revealing insights into their speed, posture, and direction of movement. In some instances, trackways suggest a sudden acceleration, possibly in response to a threat or opportunity. Marking the end of an era. 66 million years ago, the late Cretaceous period drew to a close, leaving behind a legacy etched in stone. The Triceratops, a symbol of resilience and adaptation, continues to captivate our imagination, reminding us of the fleeting nature of existence and the enduring impact of life on Earth. Not due to a lack of strength or adaptability, but rather because the subsequent events spared almost no one. The Triceratops, one of the so-called last dinosaurs, was a creature that roamed the Earth until the very brink of the Mesozoic era's twilight. Its remains have been unearthed mere meters below the Cretaceous-Paleogene boundary, a slender geological layer that marks one of the most significant mass extinctions in Earth's history. This placement in the stratigraphy indicates that the Triceratops persisted until the closing chapter of the dinosaur saga, succumbing not in isolation, but as part of a sweeping cataclysm. The cataclysmic event that sealed the fate of the dinosaurs is a tale oft-told in scientific chronicles. A celestial body, approximately 10 kilometers in diameter, collided with our planet near the present-day Yucatan Peninsula. The impact unleashed a cascade of environmental upheavals, ushering in a period known as the impact winter. The ensuing atmospheric dust and aerosols obscured the sun, triggering a dramatic global cooling that devastated plant life. In the absence of flora, herbivores dwindled, and with them, the apex predators that relied upon them for sustenance. The Triceratops, despite its formidable size and strength, was a herbivore, intrinsically linked to the plant life that nourished it. A tantalizing question arises: could the Triceratops have survived the asteroid's wrath if not for the subsequent impact winter? Had the catastrophe been confined to the mechanical impact, necessitated vast amounts of daily sustenance, and even a brief scarcity would have imperiled the species. In a hypothetical world devoid of the cataclysmic asteroid, the Triceratops might have continued to thrive in the rill. The Triceratops is profound and enduring. It holds the distinction of being the official state fossil of both Wyoming and South Dakota, testament to its emblematic status in American dental bodies, standing alongside the Tyrannosaurus and the mammoth as icons of the prehistoric world. Yet the scientific significance of the Triceratops transcends its symbolic representation. Through the study of Triceratops and other ceratopsids, researchers have crafted intricate models of ontogenetic development in dinosaurs, elucidating how a single species can manifest varying appearances at different life stages. This understanding has prompted a re-evaluation of numerous dinosaur species, many of which have been reclassified as juvenile forms of known taxa. The Triceratops has thus become a model organism in the study of ceratopsid growth patterns. Moreover, the Triceratops has contributed to our comprehension of evolutionary biology, particularly the development of complex structures. Its frill and horns exemplify how a single anatomical feature can serve multiple functions and evolve over time. Investigations into the morphological changes of ceratopsid frills across millions of years have enhanced our understanding of sexual selection mechanisms in dinosaurs. In contemplating the Triceratops, we find a reflection of life's intricate tapestry, woven with threads of adaptation and extinction. Its story is a poignant reminder of the delicate balance that sustains existence and the inexorable passage of time that shapes the destiny of all living things. In the vast tapestry of Earth's history, few creatures capture themes as a testament to nature's resilience and defense. Its iconic silhouette, graced with 3 imposing horns and a robust frill, has become a symbol of strengthrosity. The Triceratops evokes a sense of admiration and affinity. Perhaps it is because this creature was a herbivore, a gentle giant that defended rather than attacked, a steadfast guardian of its domain. Recent scientific endeavors continue to unravel the mysteries of the Triceratops, offering a glimpse into its complex biology. A study published in 2022 delved into the skin impressions from various parts of the Triceratops' body, revealing a diverse array of textures that varied according to anatomical regions. This discovery aligns with observations in modern large reptiles, where skin adaptations serve functions ranging from protection to thermoregulation and flexibility. The exploration of the Triceratops frill remains a focal point of paleontological research. In 2023, a team of scientists presented findings from an analysis of blood vessel channels within the frills of both juvenile and adult specimens. The vascular density varied significantly, with young Triceratops exhibiting a richer network, suggesting a greater role in thermal regulation during their formative years. The Triceratops thrived for approximately 2 million years, from 68 to 66 million years ago, marking its place as one of the most successful large herbivores of its time. What factors contributed to its enduring success? Was it the formidable horns, the sheer size, the complex dental structures, or perhaps an intricate interplay of these attributes? As we ponder the legacy of the Triceratops, we are reminded that it was more than just a horned dinosaur from textbooks. It was a 9-ton behemoth with one of the largest skulls in terrestrial history, equipped with dental batteries, a dynamic frill, and the resilience to withstand the bite of a Tyrannosaurus. A creature that navigated the perilous edge of the Cretaceous world, only to vanish with the close of an era. In contemplating its existence, we find echoes of nature's relentless drive for adaptation and survival.